Hello, in this short video we are going to investigate the following challenging problem on the topic of binomial expansion. The term independent of x in the expansion of the expression that you see on the display now is equal to, pause the video at this point and give it a try to see which one of the following given option is the correct answer to the problem. Okay, now let us solve the problem here on the board. So this expression can be viewed as a binomial expansion. Yes, so the standard formula for the binomial expansion is a plus b to some natural power n is equal to sigma. A counter like k goes from 0 up to this number n, and then I have the same number n choose k. The first term to the power of n minus k times the second term b to the power of k. So that is the standard formula for binomial expansion. So if you compare the left-hand side this with my expansion here, this expression is playing the role of a, minus this expression is playing the role of b, and comparing them, n is 10. But of course, it would be tedious if I want to work with this a and with that b. So let me try to simplify these expressions as much as possible and then continue. That would be a wiser way to. Okay, so here what I will do, I want for this part, I want to use this very famous algebraic identity that if I have a cubed plus b cubed, I can write it as a product in the form of a plus b multiplied by a squared minus ab plus b squared. So why this is useful here? So let me write the first one. So if you don't mind, let me call this one. Let me call this one capital A, and then capital A becomes equal to. So this expression can be viewed as the third root of x to power 3. This gives me the same x. And 1 can also be written as 1 to power 3. The reason I did it because I want to use this to write the expression as a product. And in the denominator, x to power 2/3 can be viewed as the third root of x squared. And this middle one is nothing except the third root of x. And the last one is just simply 1. Yes? So what happens now? I want to use this formula for this one by giving the role of the third root of x to a and giving the role of 1 to b. So this becomes a, in this case the third root of x, plus b, 1, multiplied by a squared, which is the third root of x squared, minus the product of these two, the third root of x, and then finally the second one squared, and then divided by the denominator here, which is this expression. But the good news is that this expression is exactly that expression, so I can cancel this out, and then it becomes the third root of x plus 1. Yes, 1 out. So this is the simplified version of this part. And let me call this one b. So if I want to simplify b here, so let me clean this. If I want to simplify b, x minus 1 divided by x minus x to the power of 1/2, this is equal to, I will, for the time being, let me write it like this, but let me use the search sign here, the radical sign. But I can simplify this. How? I can use the conjugate rule to factorize it, to write it as a product. Why this is correct? Because this times that is the first one squared minus the second one squared. But between these two, I can factor square root of x out. Then this becomes the square root of x minus 1. Why that is correct? Because if you multiply this back, this gives me is x minus the square root of x. That's correct. But what is the benefit? The benefit is that these two are cancelled. And then I will have square root of x plus 1 divided by square root of x, which can be written as a square root of x over square root of x plus 1 over square root of x which is 1 plus 1 over square root of x. Okay, so let me write the whole expression. So the whole expression, so yeah, if you don't mind, let me give it a name. So let me call this one I. This expression I can be written in this form. So I is equal to, instead of the first part, which is a, I put this expression, the third root of x plus 1 minus, instead of the second part b, I put this expression, but I have to be careful. The minus sign goes for the first one and for the second one. And then I have the power 10. But then the good news is that these two are also canceled, so I will get this expression, x to the power of 1/3, and this is x to power 1/2. I bring it up, so it becomes x to power minus 1/2 to power 10. So far, I haven't even used the binomial theorem. I have simplified my expression. Now this is a good place to use this formula by giving the role of this a to the first expression and b to minus this expression. So using the binomial theorem, I can write it as a sigma. I can choose a counter that always goes from 0 up to n, and in this problem is 10. And then I have n, choose k, n is 10, k is k, and then a, which is x to power 1/3 to the power of n minus k, as you see, n minus k, but n is 10, multiplied by minus x to the power of minus 1/2, which plays the role of b to the power of k. Okay? But let me simplify this expression a little bit. So this becomes sigma, k goes from 0 to 10, 10 choose k, but this is minus to the power of k, so I will write it here. But then this becomes x to the power of 1/3 multiplied by that, it becomes 10 minus k over 3, and then this becomes times x to the power of minus k over 2. But if I want to do it one more step, if I continue one more step, so this is from 0 to 10, 10 choose k, minus 1 to power k. Then because the bases are the same, I write the same base and I will add the exponent. So it becomes 10 minus k over 3 minus k over 2. So that is the formula for the expansion. But what I want to find a term independent of x. So it means I want to get rid of x. The only way that I can get rid of x is to play with the exponent of x and make the exponent 0. Because if the exponent is 0, x to power 0 is 1, and I will get a term independent of x. So what I will do, I will ask myself for which value of k this is the case that this is equal to this, because I want to have the exponent equal to 0, and this is extremely easy to solve. So I would write 3k is equal to 2 times 10, 20 minus 2k. I bring it to the other side, 5k equals to 20, so k becomes 4. If k is 4, the term is wanted. The independent term, which is my question mark, is wanted. If k is 4, if I replace k with 4, of course this becomes x to power 0, which is 1. This becomes minus 1 to power 4, which is 1. So then it becomes 10 choose 4. But 10 choose 4 can be calculated as 10 factorial divided by 4 factorial, the difference between them, which is 6 factorial. And I can simplify it a little bit. So this becomes 10 times 9, 9 times 8 times 7 times 6 factorial, which cancel that 6 factorial. And 4 factorial is 24. So 9 times 8 is 72. 72 and 24 can be simplified 3. So then it becomes 210. So the correct answer to this problem is 210. So let us go and see which option is correct. So as you see, option C is the correct answer to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.